Hello everyone. Welcome to another episode of Let's Discuss a Paper right after reading it. In the episode, we choose a paper that we want to read, and then we read it in 2 hours, and then we come back to discuss it. The paper we read today is by Debbie and Dragoy, um, published this year on Science, titled Suppressing Feedback Signals to Visual Cortex Abolishes Attentional Modulation. I need to introduce people. So today we have two people. Yota, can you introduce yourself?
Hi, I'm Yota Kawashima. I'm a research assistant, research engineer in Japan.
Okay. Hello everyone. My name is Qian Chen, and I'm a PhD student at Monash University. So today I will first give a summary of the paper, and then we'll discuss any questions and concerns. Okay, so for background of this paper focuses on a cognitive mechanism called selective attention. So cognitively, selective attention is a kind of limited cognitive resource which we kind of selectively allocate to process important stimulus to be a little bit more detailed. The neural representation of selective attention has long been hypothesized as top-down feedback connections from higher level brain areas to the low level areas to modulate the sensory processing of external stimuli there. Despite this long-standing hypothesis, there's no causal evidence for it because isolating this feedback connection without influencing the other V4 connections and also intracortical communications within an area is very difficult. So the highlight of this current paper is that it uses a novel method to isolate the feedback signals to the lower areas without influencing the other kind of pathways. So this paper focuses on the feedback input from V4 area, which is directly modulated by the higher decision-making areas, to V1, which is lower level area for sensory processing of visual input. And they did this experiment on monkeys. So for methods, so there are two major parts of the methods. One is they do some kind of surgery on the brain of the monkeys, and on the other hand, they get the monkey to do a spatial attention task. So for the surgery, they injected viruses to V4, which allows those viruses to travel downstream, my understanding, to place a fiber optic on V4 areas, which would turn off downstream too. Downstream is not the right word. I'll start again. They inject virus basically to put fiber optics on V1, which helps to turn off the terminals in V1 that's for receiving feedback connections from V4. So when they turn on the optic, the V1 will stop receiving feedback signals from V4. Yes, and at the same time, they will record neural activities in small areas in V1. And for the spatial attention task they asked the monkeys to do, they are pretty simple tasks where they just ask the monkeys to detect some kind of stimuli that are presented to the area in visual field that correspond to the recording sites on the V1. And at the same time, there are two conditions of this detection task. One is detecting the stimuli when the stimuli is presenting to somewhere they are attended to. And another condition is when the stimulus was presented without attention. So for results, what they found was that when they don't turn on the optic to inactivate V4 feedback, they found V4 neural activity response to the stimulus during attended condition was increased compared to when it is unattended. However, when they turn off the V4 feedback to V1, there's no difference between attended and unattended condition in V1 responses. So this means that feedback signals from V4 selectively amplify the V1 responses to the stimulus, which create a difference. And in other words, they reason that V4 feedback signals is kind of equivalent to, or it is attention modulation signals. And they also found that suppression of the channels receiving V4 feedback in V1 would also get transmitted back to V4 in the sense that V4 activity during the attended condition will also be reduced. And now this series of results kind of establish a connection between V4 feedback signals and attentional modulation, right? If this is the case, then when you turn off V4 feedback, which it would turn off attention, and you should also expect the behavioral performance from between attended and unattended conditions will also be the same because there's no attention. However, from how I read the results, even when they turn off the V4 feedback, their performance in the attended condition is still much better than their behavioral performance in the unattended condition. Although there's still a slight decrease compared to the attended condition when V4 signal was activated. I kind of speculated this is connected to their other set of results, which is related to how they turn off the feedback signals from V4. So the current method only inhibited V4 feedback to the upper layer of V1, whereas the other layers remains unaffected. So in a sense, these other layers of V1 were still receiving feedback and have some attention going on. So the attended condition during V4 inhibition kind of process still elicit better behavioral performance when compared to the unattended condition. So in conclusion, this study provides a causal evidence for the neuromechanism of selective attention. And suppressing V4 feedback to V1 diminished the attention-induced neural response gains. That's it.
Okay, thank you, Chen Chen.
It's not my it's not my strong suit.
Yeah, I understand. I don't understand the optogenetics part, but if I understand correctly, and they inject the virus in the neuron B4, right?
Yeah.
Okay, and then that virus somehow affect the the axon terminal in the V1 side. So it's still within the neurons in V4, but if we stimulate, or if we do laser stimulation in V1, as the virus propagate to the axon terminal in V1, so that neurons in V4 should be affected by the laser stimulation.
Oh, okay. So my understanding is they inject virus in V4.
Yeah.
And that virus, I think it kind of labels the feedback connections to V1. And then through that feedback connection, they manage to use optogenetics to inhibit the channels in V1 for receiving V4 signals.
V1.
I think this is what they did, because in the abstract, it says we use viral tools to label feedback connections from cortical area V4 targeting early visual cortex area V1. While monkeys perform visual spatial attention tasks inhibiting feedback zonal terminals in V1 without altering local intrafollicle and feed-forward influence. So they were inactivating V1, right?
Okay. Anyway, so the point is that they only try to inhibit the feedback signal and then
yes,
the local, bottom-up signals in V1, and that's very important.
Yeah.
Yeah, I don't know the detail of their method, but that's the point of this paper, I guess. And the other thing about behavioral performance, they aim to choose the power of laser so that the laser stimulation would not change the behavioral performance. That's what they said in the introduction or method or somewhere.
Really?
The reason is that I guess it's related to the experiment, the monkey experiment, and then in the monkey experiment, I guess, in order to motivate the monkeys, we need to give the reward, right? And then if, the laser is too strong or something, then maybe, the monkey learns some, reward related differences in laser versus without laser, or something like that.
Oh, I see it. I see it. I just now see it.
So yeah, but it's a little bit complicated, or not really bit, but what they want to do is super clear. They want to see whether the attention, the top-down attention is achieved by the feedback signals. That's super clear, but they did not investigate how this feedback changed the attention, the strength of attention, or how they change the behavior or something.
Yes, because they don't have another method to measure attention, I guess, without, when they try not to change the behavioral performance, then there's no way they can behaviorally measure attention.
So I could understand what they try to do, the aim of this research, but their logic and method sometimes not easy to understand for me. It's not that simple.
Yes. And also it's a bit puzzling how the unattended condition, the neural activity during non-attended condition is almost like the same as the neural activity for attended condition, but with the laser to inhibit V4 feedback. But there's no corresponding outcome measure that tells you, in both these situations, there are, less attention or there are less attention or attention has been impaired. You just don't know. All you know is their neural activities are similar.
So maybe they I haven't checked the supplementary material, and I guess they did extra analysis or recording or whatever, and present their result in the supplementary material, and maybe they discussed the effect of laser stimulation in terms of behavior and attention. But intuitively, by inhibiting feedback signal, which seems to associate with attention, then the prediction is, oh, okay, then the attention is inhibited, and therefore the performance decrease or some differences due to the laser stimulation. It's not. It's difficult to interpret, to be honest. So yeah, the feedback signal is suppressed. That's clear, but it's not, change the performance.
Yeah.
What does this mean?
Maybe we're too used to attention being measured behaviorally, so
Yeah, but I fully understand their motivation, why they want to, match the performance, behavior performance. The monkey reward related some, issues.
this cannot be done on humans, right? Oh. So you have to rely on reward when you train animals.
Attention.
Do you think it's still causal if you only manipulate the performance and measure the feedback in the brain? If you know what I mean.
Manipulate behavior.
Yes. So you make a behavioral task where you have, like those inattentional blindness paradigm. And you should be able to see, let's say, strong feedback signals and then sending to V1, amplifying the neural responses to the stimulus when participants attend to the stimulus. And when the participant do not attend to them and cannot see them at all, then there's no feedback signals. Does that count as causal, or you have to intervene with the feedback signal itself to call it causal? I think
what I can say is that they in a sense did something similar in the control where no laser stimulation was performed. Yeah, they compared the attended versus unattended. Yeah, and then from this result, it's clear that in an attended conditions, the responses, or not responses, firing rate is higher than the unattended condition.
Right.
So attention. Mm. So, mm, uh, um, I guess maybe the definition of attention is, in a sense, complicated. Because if you define the attention as the gain of responses, and this is nothing to do with behavior, then this result is super clear, and we can say that attention. But if you define attention as the increase in performance or something,
Something
or
would translate.
yeah, or our intuitively we predict that the performance should be increased by attention.
Mm.
From this perspective, as the behavioral performance is the same, so it's not easy to interpret the result. But attention. So the situation here is that even though the monkey attended to the stimuli, oh no, the V1 did not receive the feedback from V4, and the performance did not change.
Yes, something like that.
Mm.
I think it may have to do with the performance measure they use. They use accuracy, right? Target reports. A lot of times, the the attention manipulation kind of behavioral tasks, they also look at reaction time. So just maybe when they inhibit the feedback signals, the reaction time during attended condition has increased. So it takes longer time for them to report, but they still reported it. Or something like that. It does not have as strong effect as to let them completely miss a target, but maybe they're slower or something like that.
I see. I guess another reason for complication is that it's unclear whether, as we attended to something, that attention, send the feedback signals. So the attention calls the feedback signals. That's one, causal relation. And another interpretation is that as the feedback signal, it's, sent to the primary sensory area, the attention is generated. So the feedback signal calls the attentions. So if you take the second interpretation, this result does not make sense, because without the feedback signals, we should not have attention. But they said that the monkey attended to the stimuli. But if we think that the attention calls the feedback, and
that's a very metaphysical question. What is attention?
Yeah,
attention causes feedback signal.
Yeah. Causal.
I think this is a identity error that they're trying to draw, like attention modulation is feedback signal itself. Yeah.
is it possible that even though we attended to stimuli, the performance, behavioral performance, does not increase or something? This is,
Out effect.
Hmm.
I mean, attention and consciousness are most likely to be separated, right?
Yeah, different.
Hmm.
Hmm.
Yeah, I was thinking about that. So maybe, well, they just don't need that much attention to detect and perform this task. It's a kind of pop out
Hmm.
condition.
Hmm. Hmm. Yeah.
So this is the kind of situation where consciousness is not affected when you manipulate attention alone.
Hmm.
Mm.
I see. Maybe. Maybe. Yeah. Anyway, the technique they develop and they use is cool. And then
Mm.
their design is also, um, just great, wonderful. So I like this paper, but you know, mm, it was not easy to interpret the result. Mm. Yeah, the motivation is clear. I, understand that motivation, their motivation, but um, so okay, attentional modulation. Mm. They didn't say that suppressing feedback signals to visual cortex abolishes attention. They said attentional modulation. And to be honest, when I read this attentional modulation, I could not understand what they mean, and I automatically translate it into attention. But by saying this attentional modulation, what they meant, but just the gain or the change of responses or something like that.
Activity. Yeah. Yes. Oh, right.
Yeah.
So if you suppress feedback signal, there's no increase in the neural response in the lower sensory area. That's what they're trying to say. It's nothing to do with more like our kind of stuff, I guess, like the psychophysics. Oh,
Yeah. So every time I encounter this attentional modulation, I could not understand what they mean, but it's all about electrophysiological responses,
I
not
see.
our psychological attentional modulation.
Right.
Okay.
No wonder, yeah, no wonder people say this term attention has been, how do I say this? It's been used so broadly that it lacks a common definition in a sense.
I see. Okay, now I understand the title of this paper. I see. Yeah. Anyway, do you have any other comments, questions? No?
Nope.
Okay, great. Then should we finish discussion now?
Yeah.
Okay, then see you next week.
Thank you.
Bye-bye.
Bye.